Hey, welcome back. So this is 12.4. We're going to start solving equations that involve exponentials and logs. You've already kind of done this just a little bit. Like whenever you think log base 4 of 1 equals, trying to figure out what this equals, you're solving an exponential equation. You're saying to yourself, 4 to what power x equals 1. And so the solution to this equation is x equals 0, right? This part right here is an exponential equation. So what I'm saying is don't be afraid, you've done this before. Okay. All right, so let's begin with the exponential equations. And part A, we have if b to the m equals b to the n, then it's true that m equals n. Okay. So for a lot of problems, what you do is just try to get the same base on both sides. So if I have 2 to the x equals 128, for instance, I want to rewrite 128 as a power of 2. Okay, so you may have to go to your calculator and play around a bit. It's 2 to the, I don't know, what is that? 7 maybe? Yeah. Okay, so x must equal 7. All right, and it really is kind of that easy. Of course, the homework, they're going to try to trick you and make it harder. They're just trying to do their job. Let's see if we can find one that's a bit more interesting. I guess we could try this one. So this is number 4. We have 256 to the x equals 8. I want to write both sides with the same base. And 256 seems like it's just 2 times 128, isn't it? So 2 to the 8th is 256. So I could rewrite 256 to the x as 2 to the 8th to the x. Then 8 I could rewrite as 2 cubed, right? 2 to the 8th to the x, you know from your exponent rules, you can just multiply the exponents. Then you can equate the exponents. And then you can solve for x. Okay, so 3/8. All right. Let's try this guy, and then well, let's try something a little harder. Maybe I got rid of them. Okay, so this one, I don't know how hard this is, but 7. 625 to the x equals 1 all over the square root of 5. So 625 is probably a power of 5. Is it 5 to the 5? That's a little too much. 5 to the 4? Yeah. All right, so I could rewrite 625 as 5 to the 4. 1 over square root of 5 is 1 over 5 to 1/2. Then I could rewrite 5 to the 4th. That should be a 5. 5 to the 4th to the x is 5 to the 4x. 1 over 5 to the 1/2 is 5 to the negative 1/2. Equate the exponents. Divide both sides by 4. All right. So sometimes you're not going to be able to get the same base on each side. And in those cases, what you got to do is basically just take the log on both sides. So depending on what your base is, if it's base 10, you're going to take the common log, log. If it's exponential, and truthfully, in general, once you leave this class, you're going to use the ln. Well, maybe not in calc, pre-calc. You may still use the log, but once you get in the calculus, you kind of forget about log and just use ln. Okay. All right. So how does that work then? The first one I want to look at is actually number 9, unless I deleted it. Okay, so number 9, I have 10 to the x equals 2.55. Because the base here is 10, I'm going to use the common log. And I just take log on both sides. So I have log 10 to the x equals log of 2.55. Then on the left here, it's asking 10 to what power is 10 to the x. They're actually inverses, so the log and the 10 kind of cancel each other out, and you just have x. If you don't like that kind of thinking, you could always do like a power rule and have x log base 10 of 10 equals log of 2.55. And then this thing right here is just 1, right? So you end up with x. No matter how you slice it, you're going to end up with x. Okay, so it's log of 2.55. Okay. They want you to get a decimal approximation, which is, you see on the right there, 0.41. Okay, great. All right, so when you have an e as your base, then you're going to want to take natural log on both sides. Sometimes you have to isolate the exponential term before you can do that. So like in number 13, I have a little bit of work to do before I can get down the business. So 0.065x equals 4,200. Divide both sides. So again, what you're doing is isolating the exponential term first. Right? So I have e to the 0.065x equals 4,200. You can always cancel zeros, so we'll just say 420 over 105. And then we're going to take ln on both sides because we have base e. On the left, you can bring the 0.065 down in front, and you just have ln of e. On the right, ln of 420 all over 105. Ln of e, what is that? It's just 1, right? So again, ln, the natural log and the natural exponential are natural enemies, right? They'll just kind of cancel out, and what you end up with is just the exponent. Okay. All right, so you just have 0.065x equals ln of 420 all over 105. I'm going to divide by the 0.065x, and I get ln of 420 all over 105 divided by 0.065. Okay. I'll go ahead and get that in my calculator. What is it? ln of 420 divided by 105. Make sure you put all of that inside the log, and then on the outside of the log, then you divide by the 0.065. Okay. Use integers or decimals for any numbers in the expression. Oh, so first they just want that thing, and then they want the decimal. Okay, so ln of 420. I hope they don't want me to simplify that. 105. You know how they are, though. Divided by 0.065. Too many zeros there. Yeah, they want me to simplify that. 420. Just go to Wolfram. 420 over 105 is 4. Okay, well. Okay, and then they want the decimal, 2 decimals. Now I have to retype it in there. All right, great. ln 4 divided by 0.065. We don't have a light in here. Okay, so now I can see. There we go. 21.33. 2 decimals. Check answer. Yay. All right, so there's that stuff. Here's one. Let's try this one. This looks different, and it even tells you. Does it tell you what kind of? Yeah, natural logs. What's your solution in terms of natural logs? So you have 30. This is problem 14. I have 30 minus 1.2 to the x power is 0. This time you want to isolate the 1.2 to the power of x, right? So add that to the other side. You get 1.2 to the x equals 30. Then you could do ln's on both sides. On the left, you could bring down the x, but the ln of 1.2, that's not going to go away, right? It's not like ln of e where it's just equal to 1. So you kind of have to keep it. Then you're going to divide both sides by that number. Okay, so you have x equals ln 30 all over ln 1.2. Okay. 30 divided by ln 1.2. And then they want a decimal form for it. So ln 30 divided by ln 1.2-ish, 18.65 maybe, 18.65 or yay. Okay, so on to something bigger and better, hopefully. Yeah, okay. Now we want to start solving logarithmic equations. And again, there's kind of two ways to do it. The first way is just to use the definition of the logarithm. One unfortunality of the log equations is that you're going to be asked to now, guess what? You have to check your solutions. Okay, sorry. Anyways, the first way to solve these things is just, again, to use the definition. So if you have log base b of m equals c, convert that into b to the c equals m, and then solve for whatever you need to solve for. So let's see. Sure. Number 17, we got log base 2 of x equals -4. So you go 2 to the -4 equals x. In other words, x equals 1 all over 2 to the 4, just rules of exponents. And then x equals 1 over 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay. So that'd be your answer. Oh, we gotta check. Check. So when you do checks, you kind of have to keep the two sides separate. So on the right side, you should end up with a -4. On the left here, log base 2 of 1 over 16. Right. Okay, so on the left, 2 to what power equals 1 over 16, basically. And 1 over 16 is the same as 1 over 2 to the 4th. And 1 over 2 to the 4th is 2 to the -4. Okay, so that means x is -4. Or in other words, log base 2 of 1 over 16 is -4. So those two answers are the same on both sides. You get -4 here, you got -4 there. That means that thing works. Okay. So what do we say, 1 over 16? Well, some of these you just look at, it's going to be 5. You know. All right. Number 23, what you have to do first is isolate the natural log. So I have 9 plus 5 ln x equals 19. So just like before when we were isolating the exponential part, now you want to go after this ln x, right? So I'm going to go write 5 ln x equals 19 minus 9 is 10. Divide by 5, that's 2. Remind yourself what ln x is, right? It's log base e of x. In other words, e to the second power equals x, and that, I mean, by gosh, that's your answer. You can type your answer in terms of e. They want that. So e squared. Oops, I forgot to check my answer. Okay, so for my check, I have on the left side 9 plus 5 ln of e squared. On the right side, I got 19. Okay, so I got this is 9 plus 5 times e to what power is e squared? So that's just 2. That's 9 plus 10, which is 19. They're both the same, so it worked. Okay, great. Part B, I guess they just want a decimal approximation, which is crazy. I like the real answer better. E squared, put it in your calculator, 7.39er. Fantastic. Okay, great. Using Okay, and some of these problems you got to kind of use the properties of logs before you can solve the equation. So here in 25, what do we have? Log base 3 of x minus 1 plus log base 3 of x minus 7 equals 3. And this is usually where you get in the trouble with no solution issues. Because when you use the product rule, if both numbers are negative, it'll end up being a log of something positive. But you can never have something negative inside of a log. Okay, so if you've forgotten, the domain of the logarithm is always 0 to infinity. You can't put negatives in there. You can't put 0 in there. Okay, so this is the domain of the log. All right. Anyways, the first thing we have to do before we can use the rule is use product rule. So I'd have x minus 1 times x minus 7 equals 3. Then I can use the definition. 3 to the third power equals this business. I'm going to go ahead and FOIL it. And then 3 cubed is 27. I'm going to move that to the right side, set it equal to 0. It's 20, I believe. And then I'm going to try to factor it. X minus, what is it? 2 and 10. So x minus 10, x plus 2. So x is either 10 or x is 2. Then you need to check those things, right? You need to go back to the original equation. You can't kind of try the half do it, you know. You have to go back to here. All right, so x is 10. And I kind of like now just putting all the left stuff on it, so because people are so tempted to kind of work on both sides at the same time, but that defeats the purpose of the check. Okay. All right, so anyways, the right side is just 3. The left side, I need to see that simplifies into the number 3. So what do I have? 10 minus 1 times 10 minus 7. That's log base 3 of 9 times 3, which would be 27. And of course, 3 to what power is 27? That's just 3. Both sides are the same, so you're good. That's a solution. Let's try x is 2. So on the left side, you got log base 3 of 2 minus 1 plus, and I screwed up. I said you have to go all the way back to the beginning, and I didn't. I'm so sorry. You have to go to here. You can't shortchange it. Okay. So anyways, log of 10 minus 1 is 9 plus log base 3 of 10 minus 7 is 3. Okay, those are both okay. The issue is when you have a negative inside the log, is what I'm trying to get. So anyways, this will be log base 3 of 27, and of course that equals 3. It works. Okay, the other guy, though, is not going to work. So you have log base 3 of 2 minus 1. That's okay, but log base 3 of 2 minus 7 is the troublemaker. On the right, it's 3, but on the left, this thing won't work, because you got a negative 5 in there. And that right there, folks, is bad news. That means you have to throw out that as your answer, and the only answer is 10. Okay. Okay. Let me rearrange my work area again. More of the same. So these are like division first, quotient rule, and then maybe okay, and then we're into that other stuff. Let's do one last one, and then we'll make this one the video quiz. Let me put it in my notes as such. This is 12.4 video quiz, and it is number 27 from my math lab. All right. so what do we have? Log of 3x minus 9 minus log of 4x equals 3. Quotient rule. And then definition of logs. This is a common log, so it was really base 10. You get 10 cubed, which is 1,000, equals 3x minus 9 over 4x. You can cross multiply here, so 4,000 x equals 3x minus 9. Then you can move the 3x over, so you get 3997x equals negative 9. Then divide, right? So x equals negative 9 divided by 3997. Okay, let me just make sure all my little math is correct before I get carried away. 10, what did we say? To the third, yeah, that's 1,000. 4,000 minus 3, 3997, and I wonder if we can simplify that thing. 9 all over 3997. No. Okay, so I need to check that thing and see if it works. All right, so I can give myself a little more room here. All right, so again, I like to kind of just separate everything into a left side and a right side. Here's my check. So over here on the right it's 3, on the right side it's 3, and then you put all of this junk on the other side, the left side, and you're going to put that answer in there. So it's ln of negative 9 all over 3997 times 3 minus 9. Of course I run out of room. Minus log of 4 times negative 9 all over 3997. Do you see an issue there? Yeah, it's right there. I mean, this thing is going to be negative because you got a negative times a positive is negative, minus something, that will be negative, so that's bad. Here as well, right? You got a positive times a negative. Positive times a negative is negative, that's bad. You can't have either one of those. The domain is 0 to infinity. You can't put negatives or 0 into a log. Okay? And I know I accidentally put ln instead of log there. I apologize. But it doesn't matter, right? You can't put negatives in the common log. You can't put negatives in the natural log. Either way, it won't work. So ultimately what happens then is that there's no solution, right? You just cross that out. No solution. Okay. All right, let's make sure with the answer there is no solution. Excellent. All right, the next kind of problem, what you're going to do is use this other rule, and it's kind of like the first exponent rule we had. If you have a log of m equaling the log of n, then you could say m equals n. You just equate the guts of the logs. Okay, so let's try one or two. So here at 29, I got log of x plus 15 equals log of x plus log of 15. Right. So first I'm going to combine these two, the product rule. And then you can equate the guts. You could say x plus 15 is equal to 15x. Okay, move the x over, you get 14x equals 15, so x equals 15 over 14. Okay, got to do a check. So on the left, you got log of 15 over 14 plus 15. On the right, you got log of 15 over 14 plus log of 15. No negative issues going on here. On the left here, I got to find a common denominator, so I got to multiply that by 14. Okay, and then you get log of 15 plus 14 15s, it's really 1 times 15 plus 14 times 15, which is 15 times 15, right? You got 1 15s plus 14 15s, that's equal to 15 15s. So you got log of 15 times 15 all over 14. And why did I do it that way? It's because I can see on the right side, if you just use the product rule, you're going to get 15 over 14 times 15. And those then are the same, so it works. Okay. Alrighty then. Do one more maybe. Well, it's the same thing. It's the same deal. Let's see if they got any homework exercises for or applications. These are all just more of the same spiel. Okay, so one of these, this is really, I think, just, okay, so anyways, let's see what it looks like, right? This is an application. The next section is all applications on exponential growth and decay. Number 38 here, they give you a formula to model population. So these formulas are often used for population growth, modeling fruit fly growth or whatever kind of animal you're into. Leopards, I don't know. Here they're modeling human population in the United States. The population A is in millions and T is a number of years after 2000. Part A, what was the population of the state in 2000? So in the year 2000, T is equal to 0, right? So you could literally plug that into the expression for T. 0.0431 times 0 is just 0. E to the 0 is just 1. So the population at time 0 is 15.7 million folks, people. Okay. When will the population reach 18.7 million? So when will basically A equal 18.7. There's a little more work for this one. This isn't just plug and chug, right? I'm going to replace A with 18.7, put the original equation on the right here. And then you got to solve this. This is an exponential equation. I got to isolate this and then take natural logs, right? So I'll have e to the 0.0431t equals 18.7 all over 15.7. Then I'm going to do natural logs on both sides. Okay. On the left, you can bring down the exponent. ln of e is just 1, so I'm not going to bother with that. Divide. And that's pretty much it. Put it in your calculator. And, let's see. ln of 18.7 divided by 15.7 divided by 0.0431. They want it rounded to the nearest year, so this is 4. But remember, T represents years after 2000, so the population will reach 18.7 million in the year 2004. Okay. All right, that'll do it for me. Thank you for watching as usual, and I'll see you next time.